Hello dear students, good morning to all. Welcome back to the chemistry class. In the previous we discussed about the integrated rate equations, half-life, methods to determine the order of reactions, and the numericals on it. Now, in today's session, we'll discuss about the remaining concept, that is effect of temperature and effect of catalyst on the rate of reaction. So in the previous sessions we have discussed about the effect of concentrations, concentration dependent rate equations. Now temperature dependent rate equations. In today's session we will discuss about the temperature dependent rate equation, effect of temperature on the rate of reaction. Temperature dependent rate, effect of temperature on the rate of reaction. Okay, in this part, the first point is how the rate will affect with the temperature that we have discussed in factors affecting the rate of reaction in the beginning part. So as we know that a rate of a reaction increases with increase in temperature. As the temperature increases, the rate also increases. So how and why the rate increases with increase in temperature? What is the reason for that? So here basically the rate of a reaction that depends upon the temperature can be explained by collision theory. So before discussing the effect of temperature on the rate of reaction, the temperature dependent rate, so we need to discuss about collision theory. Few concepts, collision theory. So first we'll discuss about collision theory related concept. Collision theory and some related concept we'll discuss first, and then we'll deal with effect of temperature on the rate of reaction. How a rate increases with increase in temperature. So now, as we know that for a reaction is to be happen, there must be a collision between the reacting species. For a reaction is to be happen, there must be a collision between the reacting species in order to break the older bonds and to make the new bonds. So when old bonds are broken, then only some intermediates are formed which further reacts to form the product. But we know that. So in order to a reaction to be happen, the reactant must collide with each other. Collision. So in the collision theory part, this is the main basis of increase in the rate with increase in temperature. Collision theory. So here, in the collision theory, the reacting species are considered as a hard sphere which collides themselves and which leads to the formation of product. So here for general ordinary reactions, binary reactions, if you are considering, binary means what? Only two reactant species are there. Those two reactant species which collides with each other to give us to product. So when only two reactant species are there, they themselves collides with each other number of times, and which leads to the formation of product. But the rate at which the product is formed, that is also an important concept. The rate at which the reaction takes place. So here for ordinary reaction, the rate or the collision is in the order of 10 to the power of 25 to 10 to the power of 28 number of collisions per second. It is very high. Even though the reaction, it takes much time for its completion. Even though the collision rate is very high, but the reaction takes much time, That means those collisions are ineffective. You can say. If it is effective collision, then it leads to the formation of product. So here we are going to define the two terms. The formation of product depends upon the number of collision and effective collisions. Number of collision, first one. Number of collision, that is called collision frequency, and effective collisions we are going to define in the collision theory. First one, collision frequency. Collision frequency. What is meant by collision frequency? So your first point, collision frequency. Collision frequency. So what is meant by this collision frequency? In collision theory, we are defining collision frequency. Collision frequency. So in the reaction vessel, the reacting molecules which themselves collides with each other. In 1 second, in per unit volume, how many collisions are takes place? That is called collision frequency. Number of collisions per second per unit volume is called as collision frequency. The simple definition for collision frequency is number of collisions per second per unit volume is called as collision frequency. Now, in order to produce a product, the reacting molecule must and should collide with each other. So here, that means collision frequency must be more. Collision frequency is nothing but number of collisions taking place per volume, unit volume, and per second. Number of collisions per second per unit volume is called as collision frequency. So for ordinary reaction at a particular temperature, given ordinary temperatures, the collision frequency is in the order of 10^25 to 10^28. Even though the reaction is slow, that indicates these number of collisions are ineffective in producing the product. It indirectly indicates that all the collisions are ineffective except a few, almost maximum. It means among these number of collisions, only few of the collisions they are effective in producing the product. The remaining are ineffective. So to produce a product, that means in order to express the rate of reaction in terms of collision theory, we are explaining the concept increasing the rate of reactions when temperature increases. That is explained based upon the collision theory concept. So in this case, as the number of collisions increases, so the rate of reactions increases. That is one point. But the formation of rate is not only depends upon the collision frequency. Instead of this, it also depends upon two factors, two barriers. One is energy and second one is orientation. Energy barrier and second one is orientation barrier. Energy factor and orientation factors, you can say. One is energy factor. That means the reacting molecules, two reacting molecules are there. In order to break this reactant, two reacting species are taken. In order to break these reactions, the reacting molecule must and should collide. Yes, it is colliding. Two molecules are colliding with each other, but the reactant, the older bonds are not broken. So number of collisions increases, even though the reactions is not producing any product because older bonds are not broken. So the number of collisions which taking place per unit volume per second is called collision frequency. So collision frequency increases, number of collisions are more, but even though it do not producing the product. That means the first factor, energy factor. For each reacting species, there must be some minimum amount of energy is required. Are the reacting species which must possess some amount of minimum energy in order to produce the product. That is called the threshold frequency. The minimum energy which is required to produce the product. That is called as a threshold frequency. If the reacting species which having threshold frequency, then that gives rise to the formation of product. If the energy possessed by the reacting species is less than threshold frequency, then their collisions are ineffective. ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಸ್ವಲ್ಪ ಜೋರಾಗಿ ಹೊಡೆದ್ರೆ ಮಾತ್ರ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಮಿನಿಮಮ್ ಎನರ್ಜಿ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಬ್ರೇಕ್ ದಿಸ್. If the energy is less than the minimum energy, then it is just a collision. It is not effective collision. So effective collisions are those which produce the product. The collision which leads to the formation of product is called effective collision. Collision frequency definition is clear. Effective collision means the collisions which leads to the formation of product are called as effective collision. So for effective collision, the reacting species must possess some minimum amount of energy, that is called threshold frequency. The minimum energy which must possess by a reacting species in order to form the product, that is called threshold frequency. Threshold frequency, energy factor. If the energy possessed by the reacting molecule is less than threshold frequency, in the next activation energy concept we are going to study, that means some extra energy we must pass, extra energy required or extra energy supplied to the reacting species to reach its energy into threshold energy. For example, this is the level of threshold energy. Reacting species possess this much of energy, then it do not lead to the formation of product. So some extra energy is required to reach its threshold energy. That extra energy is called as activation energy, right? The extra energy required or extra energy supplied to the reacting species to reach its energy into threshold energy, because if it having the threshold energy, then it leads to the formation of product. The reacting species which colliding with each other, if it possesses threshold energy, then older bonds are broken and new bonds are found, product is formed. Threshold energy. So here, in order to produce a product, the rate of reaction that depends upon two factors. One is energy factor, second one is orientation factor. First one is energy. So collision frequency. In this we are going to define threshold frequency. Threshold frequency. Threshold frequency. Effective collision. See, these are the terms we have defined. Effective collision. What is meant by threshold frequency? Threshold frequency is nothing but the minimum energy possessed by the reacting species is known as to produce product. The minimum energy or frequency possessed by the reacting species in order to produce product are required. That is called as threshold frequency. If the energy less than threshold frequency, it do not lead to the formation of product. So for that, some extra additional energy we need to supply. That is called activation energy. Effective collisions are those collisions which are effective in producing the product. The collisions which leads to the formation of product are called as effective collision. Effective collision. One is collision frequency, threshold frequency, effective collision. So this is energy factor. Next one is orientation factor. If the reacting species, which collides in a proper orientation, then only which leads to the formation of product. Or else it's just a collision which do not lead to the formation of product. So in order to produce a product, the reacting species must possess some minimum amount of energy, that is equal to threshold frequency. And the second point is the reacting species which must collide in a proper orientation, then only the product will form. So only 2 points. For a reaction is to be happen, the reacting species must collide with each other. And the reacting species which colliding with each other, which must possess some minimum amount of energy called threshold frequency, and they must collide in a proper orientation. These are the condition for a reaction is to be happen. If these conditions are satisfied, then the reaction takes place and which leads to the formation of product, or else not. So collision frequency, threshold frequency, and effective collisions, and one more terms, energy factors, and this is about energy factor, and one more point is orientation factor. Orientation factor. So this orientation factor, there is direction. For example, NO2, nitrogen, 2 oxygens. Nitrogen, 2 oxygens. When This is NO2 molecule. When one NO2 molecule which reacting with other NO2 molecules, nitrogen dioxide, NO2 and NO2. So this leads to the formation of product N2O4. N2O4. This leads to the formation of product. If suppose this nitrogen molecule which colliding with this species, in other case, I am considering oxygen and nitrogen. So if these collides with each other with these two species, then it do not lead to the formation of product. Nitrogen. In a proper orientation when it collides, that leads to the formation of product. So one is proper orientation is required and some minimum amount of energy is required. The mustard should collide with each other. That is first condition. The mustard should collide with each other. Next, which mustard should possess some minimum energy called threshold frequency, and some proper orientation is required for a reaction is to be takes place. So this is the some basics of collision theory. Based upon this concept, I am explaining the effect of temperature on rate of a reaction. Yes. Rate of reaction. Now let's come to the point. Effect of temperature on the rate of reaction. Temperature dependent rate. Yes, repeat. What is the effect of temperature on the rate of reaction? Effect of temperature on the rate of reaction. As the rate increases with increase in temperature. Increases with increase in temperature. Effect of temperature. Effect of temperature. Effect of temperature. In general approximation rule, which states the effect of temperature on the rate of reaction. That is, the rate of a reaction is nearly double or triple when the temperature is increased by 10 degree. The rate of a reaction, rate constant at for temperature T plus 10 degree divided by rate constant at temperature T degrees Celsius, that is nearly equals to 2 or 3. The rate of a reaction when temperature is increased by 10 degrees Celsius or 10 Kelvin, because temperature difference is same, 10 degrees Celsius, then the rate of a reactions it nearly doubles or triples. This is a general approximation. So, effect of temperature on the rate of reaction. So how the rate increases? So here 2 times or 3 times the rate increases when temperature is increases by 10 degrees Celsius. 10 degrees Celsius. This is known as temperature coefficient. Temperature coefficient. Temperature coefficient. Temperature coefficient. General approximation. The ratio of two rate constants which are differ by 10 degrees Celsius is nearly, it is double or triple. The rate of a reaction double or triple when the temperature is increased by 10 degrees Celsius. 10 degrees Celsius. This is called temperature coefficient. Now the question is how and why. Again, so explain this concept based upon collision. How to explain? Maxwell-Boltzmann distribution curve. Maxwell-Boltzmann distribution curve. States of matter. First year concept, right? So here, if we are considering the reacting species, gaseous molecules, all the gaseous molecules which do not have same kinetic energy, because kinetic energy is distributed among the number of reacting species. It is distributed themselves. When it collides with each other, its energies are transferred, so therefore its kinetic energy varies. So all the reacting species do not have same kinetic energy. Some fraction of the molecules which having higher kinetic energy, some fraction will have lower energy. So here, at a particular given temperatures, we can write, so this is the curve. This is the curve. This is energy concept, energy versus, and this is a fraction of molecules, N by N naught, number of molecules, fraction of molecules which having an energy value. So here, suppose for a reaction to be takes place, so some minimum energy is required. So this is called activation energy, or we can say threshold frequency. So this much of energy is required. Energy required by the reacting molecules to form product. So this is the energy which required to take place the reaction to form the product. To collide with each other to produce effective, we can say to for effective collision, this much of energy is required. So this is the fraction where this much of collision which leads to the formation of product initially at the given temperature. At a given temperature T1. So this fraction of molecules, this is the fraction of molecule. Let's say 10, 20, 30, etc. 5, 10, 15, 20. So this fraction of molecules, only this fraction of molecules which having sufficient energy to form the product. So this is the effect collisions which leading to the formation of product at temperature T. And remaining, so this fraction, this is the maximum fraction, the maximum molecules which having an energy that is equal to this. So here collision is taking place. So this fraction, remaining fraction of molecules, they are colliding with each other. Total number of collisions, in that total number of collisions, only few fraction of molecules which are colliding with sufficient energy and which leads to the formation of product. When temperature is increased, what happens when temperature is increased? The reacting molecules which absorbs the energy, its kinetic energy increases. When its kinetic energy increases, number of collisions increases. That is in terms of collision frequency increases. As the collision frequency increases, some of the collisions becomes more effective. When collision frequency increases, that is indirectly the rate of reactions also increases. Because as the temperature increases, the fraction of molecules which having the energy which is required by the reacting molecules to take place or to form the product is increases. It is nearly double. So this is the fraction of molecules increases. So as a result, we can say the rate of reactions nearly doubles or So when temperature is increased by 10 degrees Celsius, it's T2. T2 is equal to T1 plus 10 degrees Celsius. T1 plus 10 degrees Celsius. Then the rate of reactions is nearly doubles. The rate of a reaction at a particular temperature, for example, the rate of a reaction is, let's say generally it is 2. The rate of reactions is 2 at particular temperature T. So what is the rate of reactions at a temperature more than 10 degrees? For example, temperature T1 is equal to 235 Kelvin. At 235 Kelvin, the rate is 2. Then what is the rate of reactions at 255? What is the rate of reaction at 255? 8. Because 35 to 45, 10 degree. When 10 degree increase, the rate of reaction become double. Usually it is double. That means it become 4. Again 10, 8. So 2 to the power you need to take. Generally, when the temperature is increased from T1 to T2, the rate of reaction increased by 2 to the power if the rate of reaction doubles. If it is given in the problem, if it mentioned the rate of reaction triples, then you need to take 3. Or else in general approximation, temperature coefficient is nothing but the ratio of rate constant at two different temperatures. that is equals to 2. So 2 to the power difference in the temperature. Difference in the temperature. So this is the effect of temperature on the rate of reaction. So as the temperature increases, rate of reaction increases. The reason is when temperature increases, collision frequency increases, effective collisions increases, there is fraction of molecules which having sufficient energy that also increases, therefore it leads to the formation of product readily and hence the rate of reaction increases. Next, so here a quantitative relation between the rate and temperature is given by Arrhenius. So Arrhenius equation. So here the quantitative relation Arrhenius equation. A quantitative relations which is given by Arrhenius. Rate is equals to A into e to the power minus EA by RT. Minus EA by RT. The quantitative relation between the rate with the temperature. When temperature increases, rate of reactions also increases. So here, where K is rate constant, A is frequency factor or Arrhenius factor, we will call Arrhenius factor. EA is energy of activation, or it is called activation energy of activation. R is gas constant, universal gas constant. T is temperature. Arrhenius equation. So from this we can derive the equation for activation energy. So if we take a log on both sides to this expression, take log on both sides for this expression, take log or natural ln on both sides. It gives ln A is equals to ln A plus ln e to the power minus E by RT, because it is A into B. Ln A plus ln B. Simplify this again. Ln K is equals to ln A to the power x. Log A power x can be written as x into log x minus A by RT into ln B, minus A by RT into ln B. Now convert this ln into log. How we can convert? By multiplying 2.303. So 2.303 log A, that is equals to 2.303 into log A minus EA by RT, because ln E is equals to 1. EA by RT. Ln E is equals to 1, and after this I have converted ln K and ln A, ln to log by multiplying 2.303. So to this expression, divide by 2.303. When the whole equation is divided by 2.303, it gives log A is equals to log A minus EA divided by 2.303 R. 2.303 RT. 2.303 RT. This is the expression. Now this is in the form of y is equal to mx plus c. Look at this. This is in the form of y, variable y is equals to mx plus c. 1 by t. 1 by t is x mx plus c. Y is equal to mx plus c. So if we plot a graph of x versus y or y versus x, if we plot a graph of y that is log K versus X 1 by T. Log K versus 1 by T. We'll get a straight line. Since it is negative sign, so negative curve, negative. So straight line with negative slope. So this intercept is C. Intercept that is equals to log A, and the slope of this curve ABC, slope is equals to AB by BC. So this gives us the slope of the curve gives minus EA by 2.303 into R. Slope is equals to M. Slope is equal to M. Graphical representation. Activation energy can be calculated by this graph. Activation energy is equals to slope into 2.303 into R. Directly, activation energy is minus E equals to minus 2.303 R into slope of this curve. Activation energy is equals to minus 2.303 R into slope of this curve. Activation energy can be calculated by this curve. And alternatively, so this is the expression at a particular temperature T1. Now, if two different temperatures are considered, at temperature the rate of reaction changes, that is increases, and temperature is T1, the rate constant is K1, and the expression is given by log K1 is equals to log A minus EA by 2.303 R T1. 2.303 R T1. When temperature is T1, the rate constant is K1. At temperature T2, when temperature is increased, then the rate constant it is K2. Log K2 is equals to log A minus EA divided by 2.303 R T2. R T1 and T R T1 and T2. Take the difference between these two terms. Take the difference between equation 1 and 2, log K1 and K2. Equation 1 and equation 2. The difference between log K1 and K2 is K2, K1. Log K2 minus log K1, which gives this to log K2 minus log K1. Log K2 is nothing but log A minus log K2 is equals to log A minus EA by 2.303 R T2. This is log K2 values. Log K2 minus log K1. Log K1 is nothing but log A minus this term. Log A minus EA by 2.303 R T1. Simplify this. So it is log A minus EA by 2.303 R T2 minus log A minus of minus plus EA by 2.303 R T1 minus log A plus log A get cancelled. EA by 2.303 R is common. EA by 2.303 R is common. So if you take this common, 1 by T1 minus 1 by T2. So this is log A minus log B. We can written as log A by B. Log A minus log B can be taken as log A by B. So log K2 by K1 is equals to EA by 2.303 R into 1 by T1 minus 1 by T2. This is the expression for activation energy at two different temperatures. Activation energy can be calculated by knowing the rate constant values. Calculate the activation energy. When temperature is rise by 10 degree, the rate constant becomes double. The rate of a reaction doubles. What is the activation energy for the reaction? Calculate the activation energy for a reaction when the temperature is rise by 10 degree, its rate constant or the rate of reaction doubles. T2 minus T1, this one. So if we use log K1 minus K2, then we get log T2 minus 1 by T2 minus 1 by T1. But I have taken log K2 minus K1. So if you take log K1 minus K2, then definitely you will get 1 by T2 minus 1 by T1. And in this case, it is log K1 by K2, not K2 by K1. Log K2 by K1, log K2. Look at this. Temperature, at low temperature, the rate constant value is less. As the temperature increases, rate constant values increases. Higher values by lower values. T2 is greater than T1. So this values will come in positive. If T1 by T2 minus 1 by T1, then its value is negative. It becomes negative. And here this also becomes negative because K1 by K2 will get cancelled. So if we selected K2 minus K1, then it is T1 minus T2. 1 by T1 minus 1 by T2. If reverse, we will get different according to that. So this is the expression to find activation. One question. The rate of a reaction doubles when temperature is raised by 10 degrees. Calculate activation energy. Single calculation. The rate of reaction doubles when temperature rises by 10 degrees. Calculate activation energy. So using this expression, can you calculate the activation energy? What they are given? Rate of reaction doubles when temperature is raised by 10 degrees. Calculate activation energy. That means initial K1 something is given. I don't know the values, but it doubles. When you take the ratio, what is the answer? 2. Because the rate of, if its value is x, then the rate becomes double. It becomes 2x. So 2x by x, 2. That is log 2. And remaining term, temperature difference is given when the temperature is raised by 10 degree. 10 degree. So T1, T2 is required. So assume that when temperature at 295 and temperature is 25 degree, 35 degree, 25 is 298, 35 degree, 308, 10 degree difference, 98 and 0. So temperatures are given. And temperature is rise from 298 to 308 Kelvin. The rate of reaction doubles. Calculate activation energy. Rate of reaction doubles. That means the ratio is 2. Rate of reaction double 2x by x. The rate values that is equals to activation energy divided by 2.30. What is the value of R? 8.314 into 1 by T1 minus 1 by T2. 1 by T1 minus 1 by T2. Let's simplify, solve the problem. Activation energy. Activation energy. Simplification and substitution and simplify. Look at this. Effect of temperature. That is, temperature increases, rate of reaction increases. Now today we will discuss another concept, that is activation energy also. Activation energy we have defined EA. What is meant by activation energy? Graphical representation. Concept of activation energy. So for a reaction, this is the energy of reactants. Energy of reactants. Reactants energy. And the energy of product. The product energy is this, and this is the reaction progress of the reaction. The reactants, first it is converted into activated state, and then we should use the product. Energy of reactant is more than product. That means whether in this reaction energy is liberated or required, whether it is exothermic reaction or endothermic reaction. Exothermic reaction. How much energy is liberated? That is equal to the difference between these energies. So this much of energy, this is delta H. That is equals to product minus reactant. So here energy is liberated. So here it is exothermic reaction. Correct? So for exothermic reaction, this is the curve. And look at this. In order to take place this reaction, the reacting molecule must collide first point, and the reacting molecules must possess some minimum energy, that is called threshold energy. So this is the threshold. Activation state where the reaction is taken. But here the energy of reactant is less. So some minimum excess energy we need to supply to reach this energy. So this energy is called as activation energy. So this is the amount of energy required to activate the molecule. The energy required to activate the molecule, that is called activation energy in this case. So this much of energy is required for the forward reaction. So for backward reaction, if I want the backward reaction product to the reactant, how much energy is required? So this is the energy required, activation energy for backward reaction. This is backward reaction and this is for forward reaction. Since the activation energy of forward reaction is less, so it proceeding in this direction, it is exothermic. So what is the nature of curve for endothermic? Reactants, products. Reactants and products. So reactants energy and product energy. So this much of energy is required. It is positive. Positive. This much of energy is required to express this reaction. Reactants and products. Reactants and products. So this is the activation energy for forward direction, and this is the activation energy for backward direction. Now, can you predict in which direction the reaction proceeds? Backward, because the activation energy of backward direction is less than forward. So the reaction proceeds in that direction where the activation energy is less. The reaction proceeds in that direction where the activation energy is less. And the difference, the energy difference between reactant and product is nothing but that is the amount of energy either liberated or required. The first one is exothermic, energy is liberated, and second one is endothermic, so this much of energy is required. Concepts of activation energy. So usually the older bonds are broken and new bonds are formed. Intermediate steps. First reactants, intermediate steps, and product. Activation energy concept. And the same reaction, effect of catalyst. If we use some catalyst in the reaction, then the catalyst, what is meant by catalyst? Yes, which is a substance which alter the rate of reaction. Either it increases or decreases. Usually positive catalyst is nothing but rate of reaction increases. Rate of reaction increases. So in the presence of a catalyst, it changes or it finds an alternative path for the reaction. This is the actual path. In the presence of catalyst, it finds an alternative path for the reaction. So that is by decreasing its activation energy. Look at this. In the first case, activation energy is more, but in the second case, activation energy is less. So a catalyst which increases the rate of reaction by decreasing its activation energy. That is the effect of catalyst. In simple words, you can mention that point. Effect of catalyst also. Effect of catalyst. So how a catalyst alters the rate of reaction? By changing its activation energy. A catalyst can alter the rate of reaction by finding an alternative path. Positive catalyst means which decreases the activation energy and hence increases the rate of reaction. As the activation energy decreases, the rate of reaction increases. When activation energy decreases, rate of reaction increases. This is the effect of catalyst on the rate of reaction. Effect of temperature, effect of catalyst, along with few concepts on collision. Okay. So you need to solve the number of problems on activation energy. In the next class, we will discuss about the numerical problems on activation energy and related to the kinetics, chemical kinetics.